Hi, my name is Frank Rosditas. This is my at week 6 submission for FTT 122. Today's date is 4/20. Happy Easter, everyone. Today we're going to be talking about 7 different subjects in 7 minutes. Well, less now with the introduction. So, brief definition of the 7 topics. Gyroscopic drift is the first one. Gyroscopic drift is the rotation of the projectile. Now, this is a USP projectile. It's a little fun gadget, but we're going to use this. So when the projectile leaves the barrel, we all know that there's either a right twist or a left twist. So we're going to go ahead and talk about a right twist, and I'm going to over-exaggerate this, okay? So with the right twist, gyroscopically, the bullet or the projectile is spinning. So it is spinning. Gyroscopically, the round will be pulled towards that direction. So if it's a right-handed spin, it's going to tend to go to the right a little. If it's a left-handed, it'll go to the left. That is a gyroscopic spin. Next is drag. Drag is the resistance the projectile encounters during flight. Basic definition. So what we're talking about, as soon as that projectile leaves the chamber, or as soon as the projectile leaves the barrel, it's going to immediately be affected by the air around it. So depending on humidity, temperatures outside, cold, wet, you're looking at a lot of different factors which you need to research on your own. But the biggest thing is the force being pushed against that projectile while in flight is considered drag. That's what drag is. Magnus Effect. Your Magnus Effect is the spinning of the projectile. And so, again, we're going to use right-handed spin. So as it's spinning, wind is blowing against it. So as the projectile's going and the wind's blowing this way and it's spinning to the right, your projectile will actually get a little bit of lift from that. Okay? So that would be the Magnus Effect. Now, of course, opposite sides, let's say, it's spinning and the wind's blowing, you're going to get a little bit of a downward. So depending on the wind, depending on the spin, you're going to either go up or you're going to go down. Magnus Effect. Coriolis and Eotvos effects. Coriolis effect, it actually has to do with the rotation of the Earth. Okay, so without getting too much into it, let's just say from this point angle, Earth rotates in a counterclockwise fashion, looking down from the top. Okay, if you're shooting from the North Pole towards the South Pole or to the equator, your projectile will follow the spin of the Earth, so it will go down into this direction. If you're shooting from the South Pole to the equator, your projectile will travel. Again, this is longer distances. We're talking about like the cannon cocker guys and stuff like that. That's, Battleship Missouri. You're talking about, those are the biggest things that are going to affect this and used in the equation of when they're firing their projectiles. So that's that. The Eotvos effect, Coriolis, that was Coriolis. Eotvos actually takes into account the spin of the Earth as you're traveling with the Earth. So as the Earth is rotating counterclockwise and you're shooting from east to west, your target is actually coming towards you. So as you're shooting at that target, you're probably going to be shooting a little higher. Whereas when you're shooting, or lower, when you're shooting from west to east, that target is traveling away from you. So you just imagine it's going down to the horizon, right? So it's setting. That projectile will probably go a little higher. So that is the Eotvos effect. Simple terms. Vertical angles. Vertical angles is shooting up towards the target or shooting down towards the target. Vertical angles are taken a lot in Vietnam, as these guys, got a lot of Vietnam vet friends, and they talk about when they're taking hills and hill this and hill that, and you see a lot of the Vietnam movies with Pork Chop Hill and things like that. These guys are fighting uphill and fighting downhill. That vertical angle, when you're shooting and that projectile is being shot at a vertical angle, whether it being up or down, gravity is going to affect that round. So shooting up, you're going to have more gravity affecting that round, not only to bring it, pull it back down, but also to pull it down. So you're fighting a lot of gravity going up, whereas going down, shooting down, that gravity is only working to bring that bullet down faster. Okay, that's vertical. Those are the vertical angles. Transonic ballistics performance. So when you have a projectile that's shot at at supersonic speeds, eventually it's going to slow down. So we know that supersonic speeds, supersonic rounds, they're going to envelop like basically a little shockwave buffer area in front of them. That's why they get that cone you see in these super high speed videos of the air being pushed in front of it. So it's just compact and compact. That's where you're going to get that snap for supersonics and the sound. As the round starts to slow down and the speed starts to decrease and gets into the transonic areas, the less of that cone is going to be there, and it's going to start getting to a point where it's going to start wobbling. A good round will wobble for a bit, but then will recovery and go on its regular trajectory. If you have a bad round, it starts to wobble, it's going to completely off trajectory, off course, and it's going to wobble and maybe start tumbling. And so that would be the problems with the performance going from supersonic to transonic. I hope these videos helped you to understand just the basics of these 7 topics. Look forward to seeing you in the next. Thank you.